This is a video on trigonometry. It is a topic that is covered in Appendix A of the textbook that portions of which we're using. So you will have some examples there to work at. I just want to do a summary for you here. So trigonometry basically deals with sine, cosine, and tangent, Pythagorean theorem, and right-angled triangles. So if you have a right-angled triangle, and you call the sides of this triangle A, B, and C, and the angle between C and A, we call that theta. So C is the hypotenuse. B is the side opposite the angle, and A is the side adjacent to the angle. And so there are relationships between these quantities, A, B, C, and theta, and that's basically all that trigonometry is all about, are these relationships. Now, the sine, cosine, and tangent, which you may have learned from before, the SOHCAHTOA, which is a way to remember that the sine of the angle is the opposite side divided by the hypotenuse. The cosine, the A stands for the adjacent side, and the H stands for hypotenuse. And then the tangent is the O stands for opposite, and the A stands for adjacent. Now you may wonder what these functions are. Yeah, and your calculators understand these functions. Basically, the deal was, way back in the beginning, someone must have asked the question that if they take two sticks and they put the sticks such that their one ends are together and the other ends are open, and there's an angle here. The question is, if you make the angle twice as big between these sticks, so if you go to twice this angle, does the height to which the stick rises, this height above the horizontal, does it double if the angle doubles? And you might think, well, maybe it does. If I make the angle 2 times bigger, this height gets 2 times bigger. But it turns out that's not true. It does not get 2 times bigger. It gets bigger in this relationship, which is called the sine of the angle. And so rather than being a linear relationship, like that you might think, oh, if the angle gets bigger, then the height gets bigger. Well, it doesn't. It's a curvy relationship, and it curves around like this. And this curve, they gave it a fancy name called the sine curve. And so this would be the sine of theta versus the angle theta. So that's really what these sine, cosine, and tangents are about. It's about these relationships between the angle and the heights or the lengths. So how this horizontal distance here changes as you increase the angle is the cosine. So that's what sine, cosine, and tangent are. And like I said, your calculators understand this. And you have to be real careful on your calculator. If you're going to use an angle of, say, 30 degrees, you have to make sure that your calculator, in the display, it says DEG for degrees, and it doesn't say RAD or GRAD, because we will be working in degrees. Okay, so those are the relationships for sine, cosine, and tangent. If you put the letters in, the opposite is B, the hypotenuse is C, adjacent is A, hypotenuse is C, and then opposite is B, and adjacent is A. Okay, so what are we going to be doing, and why are we doing this? We're doing this because when we are going to start dealing with forces, which are vector quantities and they have a direction, we're going to need to be able to break these forces into the sides of the triangle. So we're going to have triangles like this appearing throughout the course a lot. And you will be told 2 of these 4 numbers, and you should be able to get the other 2. So that's really the gist of it. So the Pythagorean theorem is that a squared plus b squared equals c squared. Okay, so those are 4 equations. We have 4 variables here. And another relationship that is always true for a right-angled triangle, if you go up here to this angle, call it maybe phi, phi plus theta would have to equal 90. Okay, so those two angles are 90 degrees because the other angle in the triangle is a 90-degree angle, and the total sum of all three angles is 180. Okay, so how is this going to work? So for example, if we're given a triangle and we're told that this angle is 30 degrees, and we're told that, let's say this is 2. Now I can't just go making up these numbers. This won't work out. For these other two sides, I can't make them up. They will be determined. As soon as I say it's a right angle triangle, and as soon as I define that angle and that length, well, now these are unknowns. So the question is, what is this? And what is this to make this triangle a right angled triangle? Now, if it's not a right angled triangle, there's a whole bunch of different answers for A and B. But if it's 90 degrees down here, that's the 90 degrees. There's only one answer. Okay, so let's say it's find B. So I look at this triangle and I go, I've got the angle, I need B, and I've got the hypotenuse. So which relationship is it? Well, it's the sine. Sine of theta is B over the hypotenuse. So the sine of 30 degrees is B over 2, or B is equal to 2 times the sine of 30 degrees. So make sure on your calculator that you can get the sine of 30 degrees. I put a couple of videos up on D2L that will allow you to work with sine, cosine, and tangent on your calculators. So if you need to look at that, go ahead and look at that. But the sine of 30 degrees is 1/2. So this would be 2 times 1/2, or 1. Okay, and then if we wanted to know A, well, we've got a couple of options here. Once we know B, we could do Pythagoras. So let's use Pythagoras. So we know that 2 squared is equal to A squared plus B squared. And I just worked out B. B is 1. So this is A squared plus 1 squared, which is 1. Okay, so we have 2 squared is 4, is A squared plus 1. Subtract 1 from both sides and we get 3 is A squared. And so A, square root both sides, must be root 3. And now we have A, B, and the angle. We've determined everything. So we know everything about this triangle. B is 1, A is root 3, hypotenuse is 2. Now if we had to work this angle out, this angle would be 60. Now you should be able to do these triangles even though they're upside down or sideways. If you look at this 60-degree angle up here, you'll notice that the cosine, the adjacent side to the 60-degree angle, is B. And the hypotenuse is still 2. The hypotenuse, doesn't matter what angle you're looking at, the hypotenuse is always the long side. So if we look at that triangle, it doesn't have to be that we're always looking at this bottom angle. We could be looking at this angle up here. And sometimes our triangles are going to be kind of funny and upside down like this. This is equal to 1, this is equal to 2, and this is equal to root 3. And so the cosine of 60 is the adjacent side to 60, that's the 1, over the hypotenuse. And the sine of 60 is the opposite, root 3, over the hypotenuse. Okay, so you should be able to see that relationship, even though the 60 is up at the top, as opposed to always using the angle down here, the 30. Okay, I think now sometimes we don't know the angle and you need to find the angle. So let's say this is theta and we have this is, I don't know, 2 and this is 4. Well, the question is find theta. So find this angle. So what you do is you look at these. We've got an angle, we've got the opposite, and we've got the adjacent. So we're going to use a tangent. Tangent of theta is 2 divided by 4, which is 0.5. Now when we have the tangent, but we want the angle, we use what's called the arctangent, or the inverse. I prefer arctan to inverse tan. So theta is the arctan of 0.5. And so on your calculator, it's either going to say, might say arctan, or it may say tan to the minus 1. That's not 1 over tan, that's inverse tan. But in any case, you would need to punch that out. Just quickly quickly punch that out for you. I think my calculator is in degrees. I hope so. And so this angle would work out to 26.6 degrees. Yeah. Okay, so there's a bunch that you can practice, and you'll have an assignment on that. So that's good for now.